Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Mitigating Power Loss in Distributed Generation, a novel approach with water cycle algorithm and capacitor banks. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the recent research topic that we have designed for the distribution systems. This is basically for placing the optimal DGs and the capacitor banks in order to provide the better distribution system. So let's move to the video. Before moving to the video, let's talk about that what we will cover into this. In this video, we will initially talk about in which application areas this system is to be implemented and where it can be useful. Secondly, we will talk about whatever the code we have designed, how to execute it, and what are the software requirements for it. Later on, we will talk about that what are the current problems and the current systems those are working in the same domain, and what exactly is happening in our proposed method. Finally, the experimental outcomes and the findings has been overviewed. So let's talk about the application areas. As in the distribution systems, there are a number of DG options with us. As you can see, few of the examples are like solar PVs, wind turbines, micro turbines, combined heat and power. So these are the types of the DG systems. Along with that, capacitors can also be deployed. So DG placements are beneficial in certain areas, like for the technical one, economical or environmental placements. So where we need to provide the power losses, reduction in the power losses, voltage stability, and the reliability improvement. So the application areas where this can be deployed are specifically for the power observation, means monitoring, for the electrical vehicles, home area networks, communication, renewable energy resources, and where the energy efficiency is one of the things. So there it can be there, the smart cities, for the energy distribution system. So these are the areas where the developed system can be implemented. Now the main objective of deploying the DGs or the capacitors in the distribution system is to get the stability in the voltage. So generation is distribution generations are to be added. So now let's talk about the code. So the code that we have designed will be given to you in this particular folder, under which there are a number of files. So all these files can be run in the MATLAB. So you must have the MATLAB software with you. And the MATLAB version that I am using is R2019. So you can use 2015 or the above version, but make sure the MATLAB version that you are using must be a full version or the trial one. So in order to run the code, you just need to go to the folder where the code has been placed, and you just need to copy the path and then go to the MATLAB and paste the path of the folder and press enter. When you will press enter, you can see all the files those were there in the folder can be seen here. So the files that you need to run is, this is the base WCA base DG, this is the Chaos WCA DG, and this is Chaos WCA DG with the capacitor bank, and finally an overall comparison can be seen under this file. So in order to run the code, you just need to select the file whichever you want to run. These four files can be run directly, rest are the functions, those are called under these four files. So in order to run the file, you just need to select the file and click on the run button here under the editor window. So when you will click on the run button, it will start executing the code and will show you the results. So before running this code, let's talk about that what exactly the current people are doing and what are the problems with them and what exactly we are doing. So in the domain of the distribution systems, the many researchers are already working in defining the position of the DGs in the distribution system. Along with that, many of them are also working with deploying the capacitors one. But collaborative work with both the DGs and capacitors is not being done in the previous methods. Along with that, they are using many of the optimization algorithms like you can see the optimization algorithms. These are basically the algorithms those are used to get the results where best possible solution is to be taken. So here our problem is to identify that where the DG is to be placed, and what will be the size of the capacitor bank in order to get the better stability. So many optimization algorithm like PSO, GA, genetic algorithm, gray wolf, and many other optimization algorithms are tried by the researchers. But the issues that we have identified in those are like, because in the domain of optimization algorithm we just need to generate the initial population, then by using the different iterations optimization algorithms are choosing the best solution. Now the problem that we identified with the traditional methods are like they are restricted with certain properties, like in generation of the initial population is random, so it is not dependent on the query where we need to define it. For example, uh, let's take an example that if we need to find any particular thing in an area, let's say this is an area, and if we are deploying the solution randomly from anywhere instead of being dependent on something else, so that can be one of the problem, that it will take more iteration to find the best solution area. But if it will be on some specific inputs that from where we need to start the initial search, then obviously that will be more beneficial. Secondly, the traditional optimization algorithms like PSO or WA, these were having certain restrictions with them, like they were get stuck in the local optima, and many of the algorithms are having the issues of the slow convergence rate. So in order to avoid that, what we have done in the proposed methodology, we have implemented algorithm name as WCA, uh, which is termed as water cycle algorithm, which is not a nature inspired one. This is a meta heuristic approach which is recently proposed. So this was given in 2016. So what we have done, we have implemented the approach where we are using the IEEE 33 bus system. So this is the 33 bus system data with us. Along with that, these are the parameters that we have given for the WCA. So in the proposed method, initially we have applied normal water cycle algorithm in the domain of the DG placement, and compared it with the techniques where no optimization algorithm has been, or no DG has been applied on the distribution system. So in order to see that, when we run this, you can see by normal WCA, when it is applied to the DG, when it DG is applied on the line, so it will give us the outcome in the terms of the, here you can see the voltage magnitude. So you can see when the DG is placed on the line as per the bus systems, wherever the DG is to be placed, that is decided by the WCA. So by applying that, by doing so, you can see there is a more stability in the voltage magnitude, and it is getting stable, whereas without DG there is a much fluctuation among the outcome. So from this we have shown that by applying the DG and by using the WCA, the voltage magnitude can get be stable, which is the main objective of a DG placement one, and this is the power loss by applying it. So then what we have done, we have shifted it to improving the WCA, where we have introduced the concept of Chow's algorithm, which is helping us in initializing the initial population. In the previous version, you can see here the initial population has been generated on the random basis, where in the second scenario we have applied the Chow's population generation concept, where the Chow's based population is being generated instead of being a random one. So when we are applying this, then we are comparing that what is the difference among the no DG, DG with WCA, and DG with Chow's based WCA method. So let's see what exactly the variation we got, and you can see there will be more stability here. This is with and without. So here you can see there is more stability with respect to the previous result that we have seen earlier. We will show you the result later on, where all the scenarios have been compared in a single graph. So same graphs have been calculated for all the three. Here your power loss is reducing up to 63 62.9 approx. So next to that, we have applied the Chow's WCA with the DG as well as the capacitor bank. So when I'm running this, you can see the results will be again analyzed. So in the code, basically initially we have given the bus data, for the 33 bus system. Then the initial parameters for the DG and Chow's based population has been generated. Data is forwarded to the function name P flooded flow code. Here these are the two codes with us. Here you can see the stability of the voltage is now near to 1 because the capacitor bank is showing a better improvement in stability of the voltage because it can hold the charge in itself. So these are the results that we are getting. This is the size of the DG at the end we are getting, along with the bus number, that on which bus it is to be placed, along with the capacitor size. Finally, all the three scenarios have been compared by saving their results in the mat file, and then we have run the code in order to get the comparison. So here you can see we do have the results with us, where Chow's WCA DG and capacitor based magnitude is more stable. Next to that, when no capacitor has been applied, you can see Chow's based WCA only DG placement is there. So that is the second level of the stability. Thirdly, when WCA is applied, and lastly without a DG. So you can see the results with the Chow's WCA when we just want to apply the DG, or when we need to apply both DG and capacitor as per the requirements. You can see the results are along with the bus where it is to be placed. So these are the information that is extracting by it. So what exactly this function is doing, in this function what we have done, we have given the line data which is having the in bus, out bus, resistance, reactance, L data, all the information of the 33 buses. Then we have calculated the buses from the DGs. Those are selected by the Chow's based WCA method. Then after that, calculating the voltages and all, we are finally calculating the current loss, voltage loss, and all the related method, so that finally we can calculate the loss factor from the total power or the overall power. Whereas in the capacitor bank, what we are doing, here is the function where only variation is like here, when we are giving the voltage with the absolute in the normal method. Here you can see we are giving the voltage directly with the absolute method only. Wherever in the CB based, we are checking that where the voltage is going beyond to the particular limit. So there we are applying a capacitor bank within a size of 99 to 103. So this is by applying this capacitor bank, the voltage is getting increased, and accordingly there is a more stability in the voltage magnitude. So this is basically is done in this particular code. Further modifications are still possible. So main contributions are like introducing the concept of WCA in DG placement, then improving the WCA by combining it with the Chow's population generation. Thirdly, providing the solution by only applying the DG in order to improve the voltage magnitude, as well as DG along with the capacitor bank. So then all the four cases has been developed and compared in order to show the effectiveness of the proposed system. So further modifications are still possible. For any research related to the distribution systems, capacitor bank, or the DG placement, you can contact us directly. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.